Welcome to Calculus, page 313 and 314, implicit differentiation. Excuse me. All right, here we go. So let's see, they want the slope of a tangent line. That is code to do a derivative. I notice a product here, so we'll have to use product rule. So get me started. I have Aaron co-starring with me today. Say hi, Aaron.
Hey guys.
All right, so Aaron, help me with the derivative. That'll be what? 2y. And then that product rule is going to be
First,
times derivative of the
second,
plus,
second, times derivative of the first.
okay, minus, and the derivative of x squared is what? Negative
2x,
equal to, let's see, it's 11x, so that'd be derivative is 11. Now they want a number, and they want just the derivative, so rather than solve this thing for y derivative and waste time on the AP, and they always put one of these on the AP, they never not put one on the AP, I'm just going to plug in my x's and y's and solve for y derivative. So everywhere I see an x, I will put a 2. And everywhere I see a y, I'm going to put a 3. So that will give us 6y derivative, because 2 times 3 is 6, plus 2y derivative, plus 3 minus 4, that's negative 1, equal to 11. And that gives us 8y derivative minus 1 equals 11. Add our 1. Divide by 8, so we get y derivative is 12 over 8. I don't see those choices over there, but I know 4 go into 12 3 times, 4 go into 8 2 times. So it's 3 over 2, choice E. Okay, number 2 is a related rate. It deals with radius of a circle is increasing at a constant rate of 2 meters per second. In calculus, we would say that is the change in radius over time equals to 2, and that will be a positive 2 because they did say it's increasing. They want to know the rate of increase in the area. So they want to know dA over dt. Okay, at the instant when the circumference is 20 pi meters. Now, one thing I noticed is they did not tell us anything about the radius. And I know I'm going to need that. So I wonder why they gave us this little tidbit here. We know that circumference is, what, 2 pi r, and circumference is 20 pi here. So if we solve this equation for r, that's telling us that r is 10. Because that cancels, 20 divided by 2 is 10. Now back to our problem. We want the rate of change in the area. So we're going to need the area formula for a circle. And we'll do our derivative now. So that'll be dA dt equal to, pull that 2 down, r dr dt. We're looking for dA dt. We have 2 pi. We found out that radius was 10, and dr dt was 2. Okay, so 2 times 10 is 20, times 2 is 40 pi. So our answer would be 40 pi meters square per second. Number 3, we have another implicit differentiation. This time, they are going to want us to solve for y derivative. We start out with a product, so our product rule Okay, help me here. That'll be first times what? Which is what?
2y1.
Okay. Plus the
Second.
time derivative of the first, right? Minus, what about the derivative of y to the third?
It's 3y squared.
Then y derivative equal to, and the derivative of x squared is,
2x.
and the derivative of negative 5. Okay, so this time we are going to have to solve this for y derivative. So let's collect a few like terms. Let's see, that will be 2xy y derivative plus y squared minus 3y squared y derivative equal 2x. If you recall, the way we solve these is we put all of our y derivatives on one side, and then we put everything else on the other side. So let's subtract this y squared to move it over there. So that gives us 2xy y derivative minus 3y squared y derivative equal 2x minus y squared. We can factor out y derivative in common. And now divide both sides by 2xy minus 3y squared. That will cancel. So y derivative is going to equal all of this. But I'm looking at the choices, and the most terrifying thing on the AP is to work a problem and none of the choices are your choices. But I notice it looks a lot like this one. -1 trig, right? If we multiply the top by -1 and the bottom by -1, then we can change the order, because -1 times 2x would be -2x. -1 times -y squared is y squared. -1 times 2xy is -2xy. -1 times -3y squared is 3y squared. Good old -1 trig, one of the best things that we ever learned in Algebra 1. Okay. Oh, let's see. Volume of a sphere, a snowball is melting. And the volume is decreasing at a rate of 2 cubic centimeters per minute. In calculus, that means dV over dt. Is that going to be a positive 2 or a negative 2, Aaron? Why?
It's decreasing.
Okay. And we want to know at what rate is the radius changing when the radius is 7 centimeters. And they give us the formula. Okay, we're ready to do our derivative. Do the derivative for us, Aaron. That'll be what?
We go to dt as equal to,
And then that 3 is going to come down there. Yeah, and that'll be what?
4 pi
Squared. And then we also have to implement. Gotcha. Now we can plug in the stuff. So we put a 2 here. 4 pi radius, they tell us, is 7. And we are looking for this. Okay, and that is a -2. 7 squared is 49. 49 times 4 is 196. Bye. That cancels. And then here, 2 will go into itself once. It goes into 196, 98 times. So we get -1 over 98 pi. And since that's radius, the unit is centimeters, our time is minutes, so it's E. Just looking at the choices, if I were taking the AP, I know if the snowball is melting, the radius is decreasing. I probably would have crossed that one out to start with. Okay, free response now. Okay, all right. Let's do part A. All right, water is running into this tank. So water is going in. That means that the volume is increasing. So that will be a positive 9. It's standing looking like this. All right, and it has a height of 10 and a base diameter of 10, which means, of course, the radius of the original tank has to be 5. Okay. They want to know at what rate is the radius increasing. That means I need to use this formula, and I need to get rid of the height. I need to only be talking about radius. So first of all, let's do that. I know that when the radius is 5, the height is 10. So I know at any time the radius is r and the height is h. And we know these are similar triangles, so they are in proportion. So 5/10 is equal to. All right. I don't want to use height. I want everything to be about radius in this problem. So the first thing I'm going to do is solve this equation for height. So if we cross multiply, we get 5h equal to 10r. Divide by 5, and we get h equals 2r. Now we're going to use this formula and instead of h, we're going to plug in 2r. This problem is going to work out really nice because I've got 2 over 1, that gives us 2/3. Pi, r squared times r is r3. Now we can do the derivatives. Okay, we're looking for the rate of change in the radius. So we are looking at dr over dt when the radius is 2, okay, and we know we want it when this is increasing, so we know we're going to have a positive answer. All right, so let's do our derivatives now. The derivative of the volume with respect to time is dv over dt equal to that 3 times 2/3, the 3's cancel, and we're left with 2 pi r squared dr dt. Now we can plug in the information that we were given. We know that dv over dt is 9 equal 2 pi. Radius is 2. And we are looking for dr dt. So we have 9 equal to 2 times 4 is 8 pi dr dt. We divide by 8 pi. So on the AP, I would say my final answer was 9 over 8 pi. And the radius units was feet. And the time is minutes. It's dr dt. I would not, unless it was calculator and they said round it to something, I wouldn't do that. I would leave the problem just like this. Okay, so that was part A. Let's look at part B now. They want to know at what rate is the exposed surface area of the water changing. Well, first of all, the area of the water surface is that circle right there. So they really want to know the rate of change in area. So we're going to be dealing with the area of a circle. And we want to know this. So we have dA over dt equal to 2 pi r dr dt. The radius is 2. And we found out just a second ago that dr dt, when the radius was 2, was 9 over 8 pi. So we can go ahead now and do some canceling. This is going to be nice because that 2 pi will cancel 2 going to 8 4 times. That 2 will go into itself once, 4 times 2. So the answer is going to be 9 halves. And then area, since, okay, the radius was feet, area will be square feet, time will be minutes. Okay, number 2, a sliding ladder problem. Okay, this ladder is 13 feet. It is a constant 13 feet. Okay, it's leaning against a house and the base is starting to slide away. We'll call this variable, in fact, they tell us, okay, x with respect to time. Okay, and of course we'll call this one y. When it slides away, x is going to be increasing, y is going to be decreasing. All right, and it says, okay, by the time the base is 12 foot from the house, so in other words, when x is 12, the base is going to be moving away at a rate of 5 feet per second. That means dx over dt is 5. All right. Now, we want to know how fast is the top of the ladder sliding down the wall. So we want to find dy dt. Will that be positive or negative? You're correct. The answer is going to be negative because the value of y is decreasing as that ladder slides. All right, we need a formula to help us, and we notice that we have a right triangle here, so we can use our Pythagorean theorem. We know that x squared plus y squared is equal to 13 squared. Now let's do our derivatives. So we have 2x dx dt plus 2y dy dt equal to, and the derivative of any constant is 0. All right, we can plug in our information and find the answer. So we have 2x, okay, all right, we know is 12, and we know dx dt is 5, and then we have 2y. Well, let's see, if x is 12, okay, and that's 13, we know we're dealing with a 5, 12, 13 triangle, so we know y is 5. dy dt equal to 0. So let's go ahead and just solve now. Let's see, that's going to be 2 times 5 is 10 times 12 is 120 plus 10 dy dt equal to 0. Subtract our 120. That gives us 10 dy dt equal negative 120. Divide by 10. So dy dt is equal to negative 12. And if we look at our units, that was feet, and the time was seconds. Okay, let's look at free response number 2b. We want to know the rate at which this angle is going to be changing as the ladder slides. First of all, is the answer going to be positive or negative? Since the ladder will be sliding and x will be increasing, we know the angle will be decreasing, so we know we're going to be getting a negative answer. So we are looking, okay, so d theta with respect to time is going to be negative something. Okay. We also still have the base is moving, so we have dx dt, and that's increasing. Getting an eraser thingy, let's see. And that's 5 feet per second. All right, and so let's see, okay, we need to have an equation which describes what's happening here. And we're talking about theta. We can use sine, cosine, or tangent. Since I already know that x is going to be 12, I'm just going to go ahead and go with x. So I know that the cosine of theta will be adjacent over hypotenuse. We'll do our derivative now. So instead of be a 1 there, so the derivative will be negative sine theta equal to, and let's see, that's going to be dx dt. Sorry, Oprah, if you're watching, my computer is going crazy. So my derivative is going to be negative sine theta with implicit is equal to 1/13 and then we have to be implicit also with x. Now we can plug in our information. We have negative. We need the sine of theta, which is going to be, if this is 12, that'll be 5, so negative 5/13. Okay, and we're looking for d theta dt, which is what we're looking for. Is equal to 1/13. My computer is just going crazy. Oh, Katy Perry is not watching right now. Okay, all right, and let's see, dx dt is 5. We get that from here. So we have negative 5/13 d theta dt is equal to positive 5/13. When we multiply over there, we can solve for what we're looking for by multiplying both sides by negative 13 over 5, multiplying both sides by the reciprocals. We get d theta over dt is equal, all that cancels, -1. And remember that angle is being measured in radians. In calculus, we always measure angles in radians. And the time is seconds. So our answer is -1 radian per second. That concludes tonight's homework. Thank you for watching.